So welcome back. Hello, hi, welcome to Lead Electrical Academy. So in this session, I will explain the fourth unit that is there in signals and systems. Signals and systems. This is very simple unit. In our mathematics, we already studied the Laplace transforms. And in overall fourth unit, the Laplace transforms and Z transforms, these two are very important. And coming to the Laplace transforms, or Fourier transform, or Fourier series, or Z transform, the properties are very important. So definitely you will get one question from the properties, and properties, and as well as the question will come the Laplace transform of different types of signals. And let us discuss one problem. What is meant by Laplace transform of f of t? So Laplace transform of f of t is equal to integration 0 to infinity e power minus st f of t dt. So this it is a one-sided function. If it is a two-sided function, this is minus infinity to plus infinity e power minus st f of t dt. So the main difference between the Laplace transform and Fourier transform, the Fourier transform of f of t is equal to minus infinity to plus infinity. Instead of s, the s is replaced with j omega t into f of t dt. That's it. That is the only difference. If you study Laplace transform or Fourier transform, and if you that means if you study Fourier transform, then Laplace transform is easy. If you study Laplace transform, Fourier transform is easy. So what is mean by Laplace transform of impulse function? So if you take the impulse signal can be defined only at 0, and for other values of time, then the delta of t value is 0. So Laplace transform of delta of t is equal to, so it is defined as 0 to infinity e power minus st and delta of t dt. So it can be written as e power 0 into 1 plus e power 1 minus 1 into 0, and it can be defined only for at 0 value, and this value should be equal to 1. So Laplace transform of impulse function is very important. Either you will get Fourier transform of impulse function, or you will get Laplace transform of the impulse function. And the second signal is unit step function. The second signal is unit step function. So first of all, identify the signal. So this is a unit step function, can be defined 0 to t, the magnitude is 1. This is called the u of t. So Laplace transform of u of t is equal to integration, so it can be defined from 0 to infinity. So 0 to infinity e power minus st, the u of t value is 1 into dt. So e power minus st integration, so with respect to dt, right, minus s, then you can apply 0 to infinity. If you substitute upper limit, e power minus infinity value is 0, and the lower limit minus of minus is plus 1 by s. So 1 by s. And coming to the Fourier transform, that is a Fourier transform of u of t is equal to, so integration 0 to infinity e power, s is replaced with j omega, right, j omega t and dt, then you will get e power minus j omega t by minus j omega. The lower limit is 0 and the upper limit is infinity, so then you will get the 1 by j omega. As I said, s is replaced with j omega, the Fourier transform is covered. So this Fourier transform is there in second unit, Laplace transform is in fourth unit. So after that, Laplace transform of ramp function. So Laplace transform of a ramp function. First of all, you should know what is meant by ramp function. So ramp function is t. The ramp function is t. Let's say this is f of t versus t. As t progresses, it will increases linearly. So Laplace transform of t is equal to tu of t is equal to integration 0 to infinity e power minus st into t dt. E power minus st into t dt. So this is in the UV method. If you apply the UV method, so then t into integrate this one e power minus st by minus s minus s minus s, then the limits are 0 to infinity minus integration of t differentiation is 1, again e power minus st by minus s. So the limits are 0 to infinity and here also 0 to infinity. See, integration of uv dv is equal to u into integration of v dv minus integration of u dash integration of v dv. So this is the formula of integration of uv dv. And so after integrating this, if you substitute the upper limit, it will be 0 and the lower limit will be 1 by s st s0. So this will be 0 and minus into minus plus e power minus st by minus s square. Again you can integrate it. This the limits are 0 to infinity e power minus st by minus s square 0 to infinity. If you substitute the upper limit, e power minus infinity is 0 and this is minus of minus is plus. So Laplace transform of t is equal to 1 by s square. So for this you need this, otherwise you can take like this, integration of uv v dash dv is equal to uv minus integration of u dash v, uv minus integration of u dash v. So this is about the Laplace transform of different functions, and you should know the formulas. What is meant by Laplace transform of 1 by s, Laplace transform of e power minus at, this is also very important, 1 by s plus a e power minus at u of t, Laplace transform of e power at, that is 1 by s minus a, Laplace transform of e power minus at sin bt, that should be equal to b by s plus a whole square plus b square, and Laplace transform of e power minus at cos bt is equal to s divided by s plus a whole square plus b square, and Laplace transform of t is equal to 1 by s square Laplace transform of different functions you have to remember, and sometimes inverse Laplace also he may ask, and formulas you should remember for examination. So those formulas are very important, and the region of convergence is also very important in fourth unit. So Z transform of x of n. So x of z, I am telling only sample questions. Sigma n is equal to minus infinity to plus infinity x of n z power minus n. This is the formula of Z transform. So for this Z transform, again, so properties are very important. What are the properties? Properties means linearity property, time shifting property, time scaling property, differentiation in time domain, and these are all properties are very important. So properties you have to remember, and shifting theorem is also very important. Laplace transform of u of t minus t naught, that should be equal to e power minus st naught. Laplace transform of u of t is 1 by s. So the shifting theorem is also important. So d by dt of x of t, that should be equal to s into x of s. S into x of s. And similarly, same way, the properties of z is also there, linearity property. And if x of n function is given, that you can substitute here, then expand it, then you will get the x of z.